David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember that you can adjust the playback speed as you desire. Second, you can pause the video at any point to jot down notes or write down questions. Third, you can turn on the captions so you can read my words on the screen. Before we get started, I just want to give you a heads up. This video is long. I haven't fully edited it yet, but my guess is it might be the longest lesson video I have recorded. And that's primarily because we've covered so much stuff in Chapter 3. So I just want to give you a heads up. I think it might be nice to consume this video in more than one sitting. Also, don't feel like you have to work every problem if you don't need the practice. However, if you do need the practice, it's a really good idea to do that. So go ahead and enjoy. Today's topic is a review of quadratic functions. Now before we get started, I just want to make sure that you understand that if you're not in my class at Verde Valley School, then this review comes out of the IBSL Analysis Year 1 curriculum. This is the second part of Chapter 3. So that's the content that's covered here. I'm sure there are plenty more things about quadratics that could be said, perhaps covered in the class that you're in. So just know that the material comes from that source. Okay, let's get started. So we first started looking at the forms of quadratic functions. So here's our first form, general form, which is also called standard form. And this is with the little letters ax squared plus bx plus c. That's the form for that function. Now, we have a symmetry axis. That's the symmetry axis of the parabola, and that's found by x equals minus b over 2a. Our vertex is the x-coordinate of the symmetry axis, and then that value is plugged back into the function to get the y value of the vertex. So there's your vertex. The y-intercept is, you get that for free. It's just right here. It's the c term. It's 0c, whatever that is. The x-intercepts, the way we get those is we solve the function and find them. We set the function equal to 0 and solve it. And there are 2 ways to do that algebraically. We factor or we complete the square. We can do that. Or we can do it graphically on the fancy smancy calculator and find the intercepts that way. All right, a quick practice. Here is a general form quadratic. I want you to pause the video and do this work. Find the symmetry axis, find the vertex, find the y-intercept, find the x-intercept, and then go ahead and make a graph. And I would say, make that graph a hand graph. Let's see how you did. So my symmetry axis ends up being x equals 3. Check your math. The vertex, I take my 3, plug it back into my function, do the math. My vertex is 3, negative 1. My y-intercept I get right out of the function for free, 0, 8. To get the x-intercept, I solve this function, and I'm doing it by factoring. Remember, you could use the quadratic formula, you could complete the square, or you could graphically do this on your calculator. My 2 y-intercepts are 4, 0, and 6, 0. Moving over here to the graph. Here we go. I've graphed all 4 points I found. I graphed my symmetry axis, and I put them on my graph, and there you go. All right, let's look at our second form. This is called vertex form for good reason, because you get the vertex out of that for free. Here's our form, a times x minus h squared plus k. Let's just go through this in the same order. Symmetry axis, x equals h. It's that h. Notice how there's a minus there. It's not there. So whatever you see here, you flip the sign to get that value, which is the same for the vertex, which is hk. So you take that number, flip the sign, put it there, and then the k goes there. So vertex for free, out of vertex form. The y-intercept, it's going to be the coordinate point 0, and then you take the 0 and you put it in the function, and that will spit out the y-coordinate of the y-intercept. So you get that way. The x-intercept, same as before, we need to solve for finding them. Now we have two things we can do. We can do it algebraically or graphically. All right, just like last time, let's do an example. Here's your function. I want you to find the symmetry axis, the vertex, the y-intercept, and the x-intercepts, and then go ahead and make a graph. So pause the video and do all that. Okay, let's see how you did. My symmetry axis, x equals 2. My vertex, 2 minus 2. Those I get for free right from the form. My y-intercept, I know the x-coordinate of the y-intercept, that's just 0. So I need to put in 0 in the function, do my math, and it spits out a 6. So I know my vertex is at, or my y-intercept is at 0, 6. Finally, going on to the x-intercepts, I set my function equal to 0, solve for x. So I did that here with these steps, going through there, and I get x equals 3 and 1, which gives us the x-intercepts of 3, 0 and 1, 0. Moving over to our graph, I've plotted my 4 points, labeled them, have my parabola going through those points, got my x and y axis. There you have it. Our last form, intercept form, looks like this. A times x minus p times x minus q. It's called intercept form because we get our intercepts for free. It's just right down here at p0 and q0. And notice how the signs of the p and q change. So if that's a plus p, this would be a minus p there. Okay, let's go through the list. The symmetry axis is just p plus q over 2. Makes sense. The symmetry axis is halfway between the two intercepts. So it's going to be the average of the intercepts. Notice how the signs are changed. So my minuses there do not show up here. So remember to change the signs of these when you calculate their symmetry axis. Just like before, to get the vertex, we take the symmetry axis and we plug it into the function and it spits out the y-coordinate of the vertex. So that's how you get that. The y-intercept, again, just like before, it's the point 0 and then f of 0. So you put 0 back into your function and find out what that is, and that would give you the y-intercept. Lastly, like I said, the x-intercepts you get for free right from the function. Let's do an example with intercept form. Same deal, but here's your function now. We've got that for the function. Now I want you to pause the video, find my symmetry axis, my vertex, my y-intercept, my x-intercepts, and then go ahead and make a graph. Let's see how you did. Working right along. My symmetry axis did these steps. I get x equals -1 for the symmetry axis. To get the vertex, I plug -1 back into my function, reduce it down, I get 32. Vertex is -1, 32. Moving right along. The y-intercept happens when x is 0, so we do f of 0, plug that into the function, work that down, I get 0, 30 as my y-intercept. Lastly, I'm going to pull my x-intercepts out of the function for free, change the signs, I get -5, 0, and 3, 0 for my x-intercepts. Moving over to my graph. Here we go, I plotted all 4 points, put my axis in, put my axis of symmetry in, and there you have it, my graph. Let's take a quick look at the A term. We didn't discuss that in the last 3 boards. So the A shows up in general form there, it shows up in in vertex form there, and it shows up in intercept form there. This is the same A. If your A is 3 here and you convert this to vertex form, you're going to have a 3 there. And the same thing as if you convert this to intercept form, you're going to have a 3 there. So no matter which form you use, A is the same. The other letters do different things, but the A is the same. So that's kind of a nice point of consistency. Let's quickly talk about what A does. So the sign of A, if it's positive or negative. If it's positive, the parabola opens up and the vertex represents a minimum as shown here in that diagram. So a minimum means that the function never gets below that. The y value never gets below that minimum point. Alternatively, if the sign of the A term is negative, that means the parabola opens downward and the vertex represents a maximum, which shows up here. That would be our vertex. The y value doesn't get any higher than that, so that represents a maximum. Finally, where A falls numerically also matters. So if A is between -1 and +1, so right in between there, that means the parabola is going to be wider than y equals x squared. Often we compare our parabola shape to the standard shape, the mother parabola, which is y equals x squared. So I've sketched you a nice wide parabola right there. This would be for an A between -1 and +1. Now, if A is less than -1 or bigger than +1, it makes a narrower parabola. So that's narrower than y equals x squared, and you might get something that looks a bit like that. So putting all that together, we talked about transformations of quadratics. And I want to use vertex form to do that quick discussion because vertex form is ideally suited for that. Now realize you could get a quadratic in a different form than this and still be asked to discuss the transformations. So I want you to think real hard, look at that quadratic, and I want you to list the transformations. So in other words, what does it take when we start with y equals x squared? What happens to this function when it's turned into this one? So there's a bunch of different translations there. Go ahead, pause the video, maybe flip back through your notes, and then write them down. Okay, let's see how you did. Translation. This is a slide, and we've just moved it horizontally -2 units, which is to the left. We've moved it vertically 1 unit up, so that would be the up direction. And then we've reflected it across the x-axis. That's the negative here. So instead of opening up, it's opening down. So that's a reflected parabola across the x-axis. Finally, we've compressed it with this number. It's great. It's less than -1. So our compression factor is 2. So that's the transformation of this function into that function. Now what I'd like you to do is do these two problems. This is find the equation from the graph. So I've given you 2 graphs, and I've labeled some points on there. Sometimes you're going to have to figure out points, but usually that's possible. So here are 2 graphs. I want you to come up with the quadratic function's equation for each graph. Pause the video and do that. All right, let's do this one first. What I noticed is I had 2 intercepts, so I went to Intercept Form. I just don't know my A, but I did my plug-in with my 2 intercepts, changing the sign. But then I understand that knowing this point here allows me to say that when I put 0 in for x, y should come out. So now I have one equation with one variable, that's a, and I can solve that. I work my steps down, and I get a is 3/2. So now I can come back, put that 3/2 into my function here in intercept form, and get my function is 3/2 times x minus 1 times x minus 6. Now on these kinds of problems, you want to pay attention to the prompt, because it could say, put this in general form or put it in vertex form, in which case you wouldn't be done here. You'd have to take additional steps to put that in the specified form. Okay, so if you haven't tried this one, go ahead, pause the video, try that one. Let's see how you did. So I noticed that since I was given the vertex on this one, I went straight to vertex form. Not the only way. You could have gone straight to intercept form. That would be fine. Again, pay attention to the destination form. If this one was prompting for intercept form, then a better approach would be to start with intercept form. However, I wanted to show you how to use 2 forms to come up with the equation. So I plugged into intercept form. I don't know my A, but I do know, I plugged into vertex form. A is unknown to me, but I know my vertex, so I can just take the 1, 5, switch the sign on the 1, keep the sign on the 5, and there's my vertex form. Now I can use either of the 2 intercepts, and I can plug in to find my A. So I picked the 4, 0. So that tells me that when I put in 4 for x, I should get out 0 for y. So there's the 0, and there's the 4. I crunched my numbers. I get this. I divide through, and I get my A is minus 9 over 5. So my function in vertex form is negative 9/5 times x minus 1 squared plus 5. All right, let's take a look at solving quadratics. That comes into play in a lot of places in this chapter. So first off, solving means finding solutions, which are also called the roots, which are also the intercepts. And I also forgot one more term on that. Can you remember what we also call these? They're called the zeros. Okay, so roots or zeros. So there's a lot of different vocabulary here that just means the same thing. Solve it and find them. Okay, so our first thing we did, we factored. We set the function equal to 0, and we solved by using a GCF factoring. We did product sum, and we did splitting the middle term. If you're struggling with those, let me know. I have lesson videos that cover all of that. Second, we completed the square. This is a little bit complicated algebraically. Again, if you're struggling with that, I have lesson videos you can review with those. Then we used the quadratic formula. This is a big plug and chug method that will solve any quadratic equation for you. Finally, we solved graphically using the graphing calculator and found the x-intercepts, which are the solutions to the equations. Now, you want to pay attention to the prompts. If the question asks you to solve it by factoring, you're going to have to show that you know how to use factoring to find those solutions. Of course, If it's a calculator portion, you can verify your answer with the calculator. You can also verify your answer with the quadratic formula. But if you don't show that you know how to do it by factoring, you won't get the points. Also, I want to make two comments. Roots. If the prompt is exact solution, do not take a square root that's not like a perfect square and turn that into a decimal. You will lose points for that. You need to keep your roots as roots, and you need to simplify your roots into simplest radical form and cancel if you have an ugly answer. Second thing, fractions. They come into play at times. When some of our terms are odd, we end up dividing them by 2, and we have a fraction that we square, and then we have to combine with other fractions, and that can get messy fast. There's no requirement that you do it in fractions. You can turn those into decimals. Sometimes that's easy. Makes sense, and you can get where you need to go. Sometimes it's hard to recognize perfect squares when you're in decimals. So if you do have a decimal and you're taking the square root of that, that can be tricky. So you might need to convert that back into an improper fraction. Let's take a look at the discriminant. The discriminant is just the b squared minus 4ac part of the quadratic formula. And we use the Greek letter delta, which is just the triangle, to denote the discriminant. And just make sure the root sign is not part of the discriminant. It's just b squared minus 4ac. So there's 3 states that are interesting for the discriminant. One is when it's greater than 0, one is that when it equals 0, and one is when it's less than 0. Go ahead, pause the video, and write down what's interesting about those 3 states. Let's see how you did. If it's greater than 0, it means it's positive, and we have 2 solutions, also known as roots, also known as x-intercepts, also known as zeros. All 4 of those vocabulary words mean the same thing. If the discriminant equals 0, then we're neither positive or negative, we're just 0. And we have 1 solution, root, 0, or intercepts. Finally, when the discriminant is less than 0, it's negative, and we have no solutions. Doesn't mean we have a bad parabola. It just means it does not cross the x-axis, or y is never 0. We did a lesson on quadratic inequalities, and they were a little tricky for a couple reasons. So let's take a look at one of those. One question might be posed like this: which values of x satisfy this inequality? So what it's asking you for is find the values of x that when plugged in here keep this true. So there are some values of x for which it's not true. So your task is to figure this one out. So go ahead, pause the video, see how far you get, and then come back. Let's see how you did. For this one, I went to the quadratic formula. This is not factorable, so I'm going to go ahead and find my solutions that way. You could also complete the square on this one, and that would work. So here's my plug-in step for the quadratic formula. I simplify it on down. I get 48 under the root. I have minus 4 on the bottom. 48 simplifies down to 4 root 3. And that allows me to cancel. These negatives cancel out. So I have 1 plus or minus root 3. So there are my solutions to this quadratic. Now, if you haven't continued this, pause the video and figure out how you need to answer this question. What conditions of x satisfy the function being greater than or equal to 0? Next step, you want to graph your 2 intercepts on the number line. So here's 1 minus root 3, and here's 1 plus root 3. So we know that this parabola is going to hit the x-axis at those 2 points. Then we look at our function, and we figure out where's the function negative and where is it positive. The reason we do that is we're trying to figure out where the function is positive and state the range of x that makes that true. So here's my clue. This parabola opens down. So that means that on the left and the right sides of the intercept, it's going to be below the x-axis, so it will be negative. So these 2 regions are negative. It means that between the 2 intercepts, it's going to be positive because it will be higher. So that's where the parabola is positive. You could basically draw this graph like that. I missed my point, but I think you can see what I'm doing there. And you can see that's positive, that's negative. Perfect. So now answer the question. Write the range of x, the values of x that satisfy the function being positive. Let's see how you did. Here's how I write that. I'm using square brackets because I have a greater than or equal to, and then I'm putting the bottom end of the range here and the top end of the range here. So this is this zone of our function. It's not the end members, it's this zone. Let's do a little bit of function conversion. So here we have f of x in general form, standard form. And I'm going to have you do two conversions. First one, let's convert that to vertex form. Hint, remember you're completing the square. So pause the video and go ahead and do that one. All right, this one was a pretty quick one. I take my b and I divide it by 2 and I square it. So that's minus 6 over 2 squared, and that's going to give us 9. So my b over 2 squared is 9. I add that to the function. I can't just add 9 to the function without changing it, so I subtract 9 right next to it. And then I bring down my minus 27 from up there. So now I'm all set to complete the square. This little piece right there, that's a perfect square. That factors down to x minus 3 squared. I combine my minus 9 and my minus 27, and I have minus 36. So that's that one. Pause the video for a sec. State the vertex. There you have it. There's my vertex. I switch that sign, bring that one down. So that's all I need you to do with the vertex form. Now I want you to go ahead and convert this same function to intercept form. So you might need to look at what intercept form is, pause the video, and do that. So this one was pretty straightforward as well. I'm looking for two numbers that multiply to negative 27 that add to negative 6. This is a product sum factoring problem. So I got minus 9 and 3, and that does the trick. So then these are my two factors. So here is my intercept form. Now, pause the video, state the intercept. Intercepts are 9, 0 and minus 3, 0. Remember to switch your signs when you state your intercepts. All right, let's go through a typical IB multi-step problem that basically leads you through exploring all the attributes of a function. So we're going to start this one with learning that the axis of symmetry of f of x, is x equals 1/2. So part A here might be sketch the symmetry axis. So go ahead, pause the video, start your graph, and put the symmetry axis on it. All right, let's take a look at my graph over here. I've put tick marks on my axes, each one is 1, and I've sketched my symmetry axis. That's just the vertical line that goes through x equals 1/2. Great, here we go, part B. F of x intersects the x-axis at this point n, which is 2, 0. Point M is also on the x-axis, somewhere else, they're not telling you. What you want to do here is mark and label both points. So pause the video and go ahead and do that. All right, let's take a look at that. We get point N for free. Let's take a peek. They told us that N was 2, 0. So guess what? 2, 0. I can just put that on there. M is pretty quick to get. We know that N is 1.5 to the right, so that M is going to be 1.5 to the left. So that's going to give us negative 1, 0 for point M. All right, so you should recognize that these three letters are the letters we use to write functions in general or standard form. So what you're going to need to do is be able to write the function in this form, and then you're going to be able to get your A, B, and your C. So now I want you to do just that. Pause the video, use what you have, and turn this function, write the equation for the function in ax squared plus bx plus c, and state the values. All right, so there's a big critical thinking step here that involves intercept form. What you've got to realize is that your way into this function is you know the two intercepts, so you can use intercept form to figure out the pieces that you need to convert over to general form. So I wrote intercept form up here. So now I want you again, pause the video, use what you know to do some plugins with intercept form, and then convert that, get what you need to convert that equation into general form. All right, let's take that a few steps further. I did my plugin. The key thing is that I know that it goes through this point, minus 2, minus 4. So that when x is minus 2, y is minus 4. So I put my y value over here. That's what the function is going to give us. A, I don't know, but I know everything else. My x value is my minus 2. So I plug my x value in there. Now I'm going to use what I know about intercept form, minus p minus q. Now remember, we put the numbers in, we change the signs. So this is minus 2 for the x value, plus 1 for that 1 on the intercept, and then minus 2 for this 2 on that intercept. So now what that gives me is this line, crunch the numbers, and I get a equals -1. So now I have everything I need. So what I want you to do, again, pause the video and convert this to general form and then state the values of a, b, and c. Boy, this is a long problem. Let's finish it up. So here's what we got from our last step. We got a is -1. So now I just plugged in my a in my intercept form. So this is just bringing my values from my intercept into intercept form. I multiplied the two binomials. I distributed my -1, and I get f of x is -x squared plus x plus 2. And that gives me my a, b, and my c. A is -1. We know that from here as well. B is 1, and c is 2. So that gives us the values of a, b, and c. Now, bonus question. Go ahead and use what you know to sketch the graph or complete the graph of that parabola. Just because I love my algebra, I did one more calculation. I needed to know where the vertex was. If you were being asked to draw an accurate graph, you need to find your vertex. So what I did is I just plugged my axis of symmetry into the function that we found in the last step, and I get -1/2 squared plus 1/2 plus 2. Now remember, this minus is outside of the squared. So I square 1/2, I get 1/4. I apply my minus to that, and then I just turned my 1/2 into 2/4, and I turned my 2 into 8/4. I combined them all down to get 9/4, which is 2 1/4. So my vertex is 1/2, 2 1/4. Going over to the graph, I plotted that point, and I drew my parabola, and I'm done. Whew! One last problem. I promise. There's a bunch of calculations here, so it's not a quick one, but it will be the last problem. That's a promise. Okay, so let's take a look at it. This is one of those more complicated problems we got when we dealt with a discriminant, and it's totally fair game for the test, so I want to go through this with you. So here's our function, 2kx squared plus x plus 1 minus k. So the addition is we have this k in there. It's a constant, it's a number. Okay, so if you knew what k was, then you could consolidate that function and write it in standard form or general form. So, but we don't. So here's our prompt. Find k such that f of x has 2 roots. So this is the setup. So what I want you to do is think real quick about that and come back with a strategy. You don't have to do any math yet. Just think about what you're going to have to do to figure this one out. Now, if you realize that this one comes down to the discriminant, you're right. We have a discriminant here. We need to find the k's that make the discriminant for that function greater than 0 or positive. So if we can do that, we can answer the question. So go ahead and pause the video and think about what your next step might be. Do that step. It's going to be a plugin. You're going to need to evaluate the function and do a plugin step with the discriminant. So here's my plugin step. B is just 1. There's a 1 there. So it's 1 squared minus 4 times a. The a is the 2k. Whatever is in front of the x squared term is our a. So 2k is my a, and then x and 1 and k, those are both constants. They're known, or we don't know k, but we're going to figure things out about k. So our c is just 1 minus k. So that's our plug-in step. I set it equal to 0 because we're going to solve for the values of k that make this true and then reinterpret that to get our answer. Okay, let's see how far you got. I did my plug-in step. Now I'm going to crunch the numbers. The first thing I did is I multiplied these two terms to get that, and then I distributed my 4 through to get this. And then I realized when I looked at this, this is going to be a quadratic formula thing to get my solution here, because I have, when I rearrange it in standard form, these coefficients aren't going to let me factor. I could complete the square, but I'm going to go straight to the quadratic formula. So in order to do that, I need to state this function, which is just the discriminant. It's not the entire function, but it's the discriminant based on where k showed up in the function. And that itself is a quadratic. So here's where we are, setting that equal to 0. So I want you to pause the video, pull out your quadratic formula, find the solution. All right, let's see how you did. I brought over my a, my b, my c from the last board. So here are those values. Here is my straight up plug-in step in the quadratic formula, no math done, just plugging in. And then I'm crunching numbers. So my 8 goes to positive. I'm going to end up with 64 minus 32 under the root. And that's going to be over 16. Now crunching again. I kept these the same, but I did my subtraction under the root, which gives me root 32. Now I'm going to have to simplify that root because I know I can. In fact, that's going to be 16 times 2. 16 comes out as the 4. So now I have 4 root 2 for my radical. And finally, now I can do a bunch of canceling here and get 2 plus or minus root 2 over 4. Whew! Okay, so now think back about the problem. Find k such that f of x has 2 roots. And remember, we decided that that meant the discriminant has to be positive or greater than 0. We found our solutions that make it 0. So now we just need to interpret this result to answer the question. So go ahead, pause the video, take that last step. All right, the next step is to take those solutions here and put them on the number line. So here's 2 minus root 2 over 4 is that point. 2 plus root 2 over 4 is that point. Now, I think if you have trouble figuring out where the function is negative and positive, sketching in a rough approximation of your parabola graph will help you with that. Notice how the 2k, that's our a, is positive. So this parabola opens up. So it's got to go through and then back up like that. And so remember, we're looking for values of the discriminant that are positive. So, or of the function that are positive. So that's not happening here. The function is below, this is our x-axis, is below the x-axis. So the function is negative here, and it's positive here and here. So that lets us state our solution. Now we know that the function is positive when it's less than this or when it's greater than that. So pause the video and go ahead and write the solution. All right, let's see what you got. Here's the bottom end, the bottom part of our range. We go all the way to negative infinity, but we stop at 2 minus root 2 over 4 inclusive, so that value works. And then on the other side, we start at 2 plus root 2 over 4, that value works, and we go all the way up to positive infinity. So there you have it. Or maybe not. There's a mistake there. This time I did it on purpose. I want to test and see. So take a look at how I stated my solution and figure out what's wrong. It's not inclusive. When we're here, the discriminant is 0, the root goes away, there's no plus or minus, we have one solution. Notice how it wants 2 roots. So we don't get 2 roots when the function is 0, we have just 1. So it's not inclusive. So that was a little subtlety, but might be worth points on a test. Thanks a lot. I really appreciate you watching that very, very, very long video. I hope you have good notes. I hope it helped you feel prepared for our exam, and I'll see you next in class. Now that you've watched the video, take a moment to jot down additional notes, some questions for class, or a short summary of the lesson. You can also go back and re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.